Hello dear student, in last lecture we have seen linear property and some problems on a linear property. Today we are going to start shifting property. So there are two types of property, first shifting property and second shifting property. So today we will see the first shifting property. So what is the statement of the first shifting property? So we will see the statement. If L f of t equal to f of s, then L of e raised to power a t f of t equal to f of s minus a. So this is the statement of the first shifting property. Now we will see the proof of this property. Okay. So what is given there? So we have given L f of t equal to f of s. L f of t equal to f of s. So by using definition of Laplace transform, so this term can be written as integral 0 to infinity e raised to power minus st f of t dt. So this is the definition of the Laplace transformation. Okay. So let it be equation number 1. Okay. Now to prove this theorem, let us retake LHS. So by taking LHS, Laplace transform e raised to power at f of t, and using definition of the Laplace transformation for this function. So this can be written as integral 0 to infinity e raised to power minus st e raised to power at f of t dt. So by using definition of the Laplace transform, so this term can be written as in this way. Okay. Now if we observe e raised to power minus st e raised to power at, okay, so here base is same, so taking in power minus t as a common term. So therefore integral 0 to infinity e raised to power minus t is common term. So in bracket s minus a we can write f of t dt as it is. Okay. So now to solve this integral for the simplification, so let us we put s minus a equal to p in this integral. Then the above integral can be written as left hand side as it is equal to integral 0 to infinity e raised to power minus pt f of t dt. Again by using definition of the Laplace transform or by using equation number 1, so this term can be written as f of s. Here is s, so therefore we can write here s. So if there is y, then we can written here y. If there is x, then we can written here x. So in this way we can use this definition here. So here is p, so therefore we can write f of p. Okay. So reverse replace p equal to s minus 1. So we can replace p equal to s minus 1. So this term can be written as Laplace transform e raised to power at f of t equal to f of s minus a. So this is the proof of the first shifting property. Okay. So dear student, this property is very important exam point of view. Most of time the problems will ask in examination on this property. So this property is very easy to remember. So that is L of e raised to power at f of t equal to L f of t when s changes to s minus n. Okay. When you are going to solve the problems, so then we will use this form to solve the problems, because this is a very easy form to solve the problems. Okay. So this is the first shifting property of the Laplace transformation. Now we will see some problems on a shifting property. The first problem is find Laplace transform of e raised to power minus 3t 2 cos phi t minus 3 sin phi t. Okay. So let us we see the solution of this problem. So let us we consider f of t equal to e raised to power minus 3t 2 cos phi t minus 3 sin phi t. So let us we consider f of t is a whole term. Okay. So let us we consider equation number 1. Okay. Now taking Laplace transform on both sides, we get L f of t equal to L of e raised to power minus 3t in bracket 2 cos phi t minus 3 sin phi t. Okay. Now we will use shifting property for this term. Okay. So by using shifting property, this term can be written as L of 2 cos phi t minus 3 sin phi t s replaced by s plus 3 by using shifting property, that is L of e raised to power at f of t. So here e raised to power at means e raised to power minus 3t, and f of t means that is 2 cos phi t minus 3 sin phi t. So L f of t means this term. So this can be written as f of t, that is 2 cos phi t minus 3 sin phi t, and s replaced by s plus 3. If here is plus sign, then here is minus sign. If there is negative sign, then there is positive sign. So therefore s replaced by s plus 3, because here is minus sign. So therefore s replaced by s plus 3. Now we will simplify this term by using linear property. So therefore by using linear property, this term can be written as 2 L of cos phi t minus 3 L of sin phi t, s replaced by s plus 3. Okay. Now what is the L of cos at? We know that formula L of cos at. What is the formula of L of cos at? That is s upon s square plus a square. And what is the formula of L of sin at? That is L of sin at equal to a upon s square plus a square. So these are the formulas. So by using this formula, we will solve these terms. Okay. So therefore L f of t equal to in bracket 2 L of cos phi t means s upon a square plus a square. So therefore a is 5. So s upon a square plus 5 square minus 3 L of sin at, a means 5. So therefore 5 upon s square plus 5 square. So s replaced by s plus 3. Now simplify, then equal to twice s minus 15 divided by s square plus 25, because here base is same. So s replaced by s plus 3. Now we will replace s by s plus 3 and we will use equation number 1. Okay. So therefore what is equation number 1? What is the f of t is? F of t is e raised to power minus 3t. So put f of t in this term, we get L of e raised to power minus 3t 2 cos 5t minus 3 sin 5t equal to, so 2 s replaced by s plus 3, s replaced by s plus 3 minus 15 divided by s replaced by s plus 3, s plus 3 square plus 25. So simplify, 2s plus 6 minus 15 divided by a plus b bracket square, that is a square plus 2b plus b square, that is s square plus 6s plus 9 plus 25. So this can be written as 2s minus 9 divided by s square plus 6s plus 34. So Laplace transform of e raised to power minus 3t 2 cos 5t minus 3 sin 5t is 2s minus 9 divided by s square plus 6s plus 34. So this is the simple example on a shifting property. Now we will see second problems on a shifting property. Second problem is find Laplace transform of cos h at into sin at. Okay. What is the solution? So let us suppose that f of t equal to cos h at sin at. So let it be equation number 1. So now by using hyperbolic function formula, that is e raised to power at plus e raised to power minus at divided by 2 into sin at. Okay. Now multiply this term to this bracket. So 1 by 2 taking common term. So f of t equal to 1 by 2 in bracket e raised to power at into sin at plus e raised to power minus at into sin at. Okay. Now taking Laplace transform on both sides, we get L f of t equal to Laplace transform of 1 upon 2 e raised to power at sin at plus e raised to power minus at into sin at. Okay. Now to simplify this term, we will use linear property. So taking 1 by 2 is common term and multiply L to this term and this term. So L f of t equal to 1 by 2 Laplace transform of e raised to power at sin at plus Laplace transform of e raised to power at into sin at. Okay. Now we will solve this term by using this shifting property. Okay. So therefore L f of t equal to 1 by 2 is common term. Okay. So using that property, so Laplace transform of sin at, that is f of t is sin at. So s replaced by s minus a, because e raised to power is plus a. So therefore s replaced by minus a plus Laplace transform of sin at, f of t means sin at, and s replaced by s plus a, because here e raised to power is minus a. So therefore s replaced by s plus a. Okay. So therefore L f of t equal to 1 by 2 is common term as it is. So what is the L of sin at? That is a upon a square plus a square. We know that formula. So using that formula, we can write this term. Again plus L of sin at is a upon a square plus a square, and s replaced by s plus a. And what is next? Now we replace s replaced by s minus a this term, and s replaced by s plus a in this term. Okay, and using equation number 1, f of t. Okay, so putting f of t, s replaced by s minus a and s replaced by s plus a in this term, then we get L of cos h at into sin at equal to 1 upon 2 in bracket a upon s minus a bracket square plus a square plus a upon s plus a square plus a square. Okay, so this term is as it is. Okay, now taking cross multiplication of this term and this term, so we get 1 upon 2 a into this term s plus a bracket square plus a square plus a into this term, that is s minus a bracket square plus a square, and divided by what is the simplification of this term, that is s square minus 2as plus 2a square, into second term is s square plus 2as plus 2a square. If you solve this term, we get 2s square plus 4a square, and divided by this term, and this term is as it is. Okay, so what is next step? So by taking a is common, so we get a by 2, and this term is as it is. So therefore what is left hand side? That is L of cos h at into sin at equal to, so again taking 2 is common, so 2 get cancel here, so we get only a in bracket s square plus 2a square divided by first bracket a square minus 2as plus 2a square, and second bracket is a square plus 2as plus 2a square. So this is the second problem of a shifting property. Okay, now we will stop here. Okay, so thank you.